Okay, guys, today we're going to be talking about inequalities. Let me move the screen a little bit closer. Inequalities. Um, Inequalities are solution inequalities. You know them as, other relationships between two numbers. So, for example, 5 is less than 8. Um, 9 is greater than or equal to 5. We could also say 7 is not less than 2. So what does it mean? So the idea is, what do these statements mean algebraically? So, for example, if we see x, we see this symbol, this means that x is greater than 4. Now, in an algebraic, we know that this is a set of solutions on the number line. So, for example, actually, let me change this. So, if we said, let's say we said that x equals 4. Well, we could, in one dimension, we could draw on the number line. This is 0, this is 4, and the solution is 4. And that's the only solution to this equation. Maybe it was 12x equals 48. So 4 is the only thing that works. But what if I said, I don't know, x plus 5 is less than 9? Well, you'd solve it like a normal equation, but you'd maintain the inequality. X is less than 4. Well, what's that saying? Well, there's many solutions, right? There's many solutions, right? And so, you have 0, you have 4. The question is, what solution satisfy this? Well, you know that, 0 works, -3 works, 2, 3. The question is 4 work. Well, maybe recall, when you have 4, keep an open circle here. Now, the way I remember to do this is when it's x equals something, I make it look like that, and I put an arrow. That's how I know it goes like that. Let's try another one. Let's say there is a solution, x is less than or equal to 4. Well, you know that same idea, it's the same thing, except it's now colored in. Let's take a look at flipping it around. How about x is greater than 4? Well, once again, 0, 4. We know because it's greater than, it's an open circle, so 4 is not included. And my little trick is when you have x relation something, make an arrow like that, so you know, okay, it's like that. And then the last thing is simply, x is greater than or equal to 4. Same idea. We know that for 0, we know it goes to the left, but 4 is included. Now, these are simple solutions to algebraic equations. The idea is you keep when you solve it, a little thing before we move on, something called a compound. Something called compound inequalities. The first example I'm going to give you, for example, I would like you to think about how do you define the ages. What are the ages of teenagers? Okay. And the next thing I'd like you to think about is who gets a discount at a movie theater or, an amusement park? Who gets the discounts? So what ages of people, get discounts at the movies or an amusement park? Sorry, I'm writing really fast. I want you to think about that. Once again, what are the ages of someone you call a teenager? And who gets discounts at the movies? I want you to think about that. Okay, well, you might say, who's a teenager? So you'd say, okay, well, you have to be greater than or equal to 13, and what else? What other condition has to be met? You also have to be less than 20. Now, some kids might say 19, but then I say, well, can you be 19 in 3 months? Or are you still a teenager? And you would say, oh yeah, I'm still a teenager. So the idea is, when we use the word and, we're looking at an intersection of inequalities. So you might say, okay, if you are a teenager, you're greater than or equal to 13, and, right, you're less than 20. So we would say this inequality, we would write it as 13 is less than or equal to x is less than 20, and we would write it as, closed circle, and then open circle 20. And this is the idea of a compound inequality, where two conditions must be met. Well, the next case is something a little bit different. For example, who gets discounts at the movie theaters? Well, you might say, I want you to think about that. Okay, you're saying, okay, I know two groups of people who get discounts at the movie theaters. First, kids under 12. So you might say X. So you might say, let X be the ages of people. And so the first group who gets a discount is X less than, or equal to 12. Sorry, discount. Discount. But who else gets a discount? You might say, oh, senior citizen, so like over 65. Now, the question is this an and or an or? And you say, well, it has to be or, Mr. Riley, because those two things can't be you can't be less than 12 and greater than 65. So this is an or. Now, we kind of have an idea what it looks like graphically. You might say, okay, Mr. Riley, just start at 12 and then start at 65. And these are so this is what the graphical solution looks like. How do we draw it using using inequalities? Well, it kind of looks funny. X is in the center, and instead of going to the left, the arrows go to the right. And so X is, so let's see. Yeah, X is less than or equal to 12, or, it's kind of weird looking. I get confused, kids like this. Or X is greater than or equal to 65. So this is an or, and this is an and. We're not going to spend that much time on it, but it's just something to think about when compound inequalities show up. These are some real-life situations. Okay. Let's just take a look at the algebra now. We'll take a look at the algebra, and then we'll take a look at some graphing. So, first of all, if A is less than B, and B is less than C, then we can conclude that A is less than C. Also, if A is less than B, then A plus or minus C is less than B plus or minus C. So you've learned in previous algebra classes that you can add or subtract, and it maintains the relationship. That's something we really need to think about, this is a relationship. Until recently, you've been maintaining equality. Now I want to maintain the inequality. And so adding and subtracting does not affect that. But there is a little thing. If you multiply or divide by a negative, you must flip the inequality. Right? So let's take a look at some examples. Can you see me? Yeah. The first example is 3x minus 4 is less than 11. 3x minus 4 is less than 11. So you say, okay, add 4 to both sides. We have 3x is less than 15. We're still maintaining this inequality. And on the last step, we divide both sides by 3. X is less than 5. We didn't have to flip it because we were just dividing by 3. Next example, how about 4 minus x is less than or equal to 3x minus 8. What's great about this is if you put in this in Desmos, it gives you the, you can visually see what the answer is. So let's manipulate this algebraically. You can do it, I'm going to just do it by hand. So you can either, you learned, we know the last answer is x relation something. So you know what, I'm going to subtract 3x from both sides. So I have 4 minus 4x is less than or equal to negative 8. I'm going to subtract 4 from both sides. So now I have negative 4x is less than or equal to negative 12. And then my last step is to divide by negative 4. When I divide by a negative, I have to flip the inequality. Final answer, x is greater than or equal to 3. Please go to Desmos and put this equation in, and you'll actually see, it's kind of cool. You'll see like a big screen, and you'll see a solid line, and you'll see like this whole thing shaded in. I think it's kind of cool. Last example I'd like to do, 4/5 x plus 7 is greater than 8x plus 2. It's a little advanced, but some of you might be thinking about taking analysis next year, and I want you to, just know how to do these algebraic skills. So what do we have here? Well, I'm going to move the 7 to the other side. Actually, what should I do? Well, Mr. Adler's technique, I don't like fractions. So the first thing I'm going to do, how are we doing for time? Good. The first thing I'm going to do is I'm going to multiply, I'm going to get rid of that denominator. I'm going to multiply every term by 5. 5, 5, 5, 5. I can multiply everything by 5 and maintain the inequality because that's a rule. So let's see what I can do here. Well, 5 goes out with the 5. I have 4x. 5 times 7 is 35. 5 times 8x is 40x. And 2 times 5 is 10. Remember, I'm multiplying. So what do you think we should do? Well, you were taught to bring all the variables to the left and the numbers to the right. But you know what I want to do? I don't want to deal with negative numbers. So I'm going to move the variables to the right. So I have 35 is greater than, 36x plus 10. And then what I'm going to do is I'm going to bring the 10 over to the left, subtract 10 on both sides, and I have 25 is greater than 36x. Well, this one looks a little weird to me. So you know what? I'm just going to fix it up a little. If 25 is greater than 36x, that means that 36 is less than 36x is less than 25. X is less than 25 over 36. I didn't flip because I divided by a negative number. I just flipped it because I want to keep the variable on the left. Let's continue. Compound. Good. Yeah, let's move on. Now let's do graphics. So you know what? I'll put both lessons in today. So let's talk about graphing inequalities. So, graphs. Now, I was really pushing the idea of sketching because I want you to, know how to do sketch. So let's just go over the basics. So first of all, let's say I give you y is less than or equal to 2x plus 1, right? Or, you know what? It's in the form, we have it in the form of y equals mx plus b. And we're going to look at different cases here. It could be less than or equal to, it could be, greater than or equal to, it could be less than, or it could be greater than. So regardless, step one, sketch the graph as if it were an equality. Okay. Now so you look at this, you go, okay, I know y equals 2x plus 1. Let me do it on the side. So right here you go, oh, you know what, it looks like that. I know it looks like this. I know the 1 is the y-intercept, and I know the graph is increasing. We're not doing graphs, we're doing sketches. Now the only difference is right here, if you have greater than or equal to or less than equal to, use a solid line. If you have less than or greater than, use a dotted line. So in this case, in the first case, right, the original problem that I wrote, I said y is less than or equal to 2x plus 1. The first thing you would do is you would draw a line like that, and because it's equal to, the points are included. You include the line. Now the next thing is, well, we know that there's a lot of solutions here because with inequality, there's a lot of solutions. Now here's the little trick. The little trick goes like this. If it's y is less than, then you're going to shape everything underneath. That's a little trick. But what's the better way? So you're going to test for shading. Test for shading. You're going to test 0, 0. If 0, 0 satisfies y is less than or equal to 2x, shade the region including which includes 0, 0. If it does not, shade the other region. Okay, so let's talk about this a little bit more. So I'm talking about testing, I'm talking about shading, and I'm talking about regions. So let's go back a step. We sketched our graph. You said, okay, y equals 2x plus 1. And we know because they're equal, it's solid. Well, let's take a look here. What I've done, whenever you graph a line, you create an upper region and a lower region. We do not have a left and a right. No, you have an upper and you have a lower. Think about like the vertical line test, right? We have an upper and a lower. So the question is, what do I shade? Now you can see in decimals what the answer is, and also I told you, because y is less than the expression, we're shading underneath. The last thing I told you was the testing. Let's take a look at 0, 0 here. Let's see, let's test, is 0 less than or equal to 2 times 0 plus 1? And you say, oh yeah, yes, 0 is less than or equal to 1. Therefore, 0, 0 gets the shade. 0, 0 gets the shade. Let's try another one. Ready? Y is greater than, y is greater than negative 3x plus 2. Y is greater than negative 3x plus 2. Okay, so you say, okay, Mr. Adler, I know how to graph this line. Oh, the great thing about graphs, you get to use pencil. Why do you get to use pencil? Watch. So you say, okay, I know my line is decreasing, and I know it crosses through at the y-intercept is 2. And then you say, wait a minute. It's just the greater than, so it's a dotted line. It's a dotted line. Now, what area gets the shade? Well, the other trick is, because it's y is greater than, we know it's above. But that's a trick. Let's see if it works. Well, test 0, 0. So we know the shade is above, but we didn't do the test. So test 0, 0. Let's see, is 0 greater than negative 3 times 0 plus 2? Is 0 greater than 2? No. So 0 does not get the shade. We shade above. We shade above. Let's try this one. I'm about to teach you a trick, actually, so let's change it up a little bit. Let's change this up. How about this one? Ready? 3x minus 5y is less than or equal to 15. Now, you look at that and you go, oh, that's the graph with the intercepts. We know whatever line we have, we know that it's solid line. But this is with the intercept. But here's a trick that Dareen, she taught me last year, because her tutor taught this, and then I learned it, and I love it. Ready? If it's, remember it's in this form, take this 15, right, and divide everything by 15. And we get x over 5 minus y over 3 is less than or equal to 1. Are you ready for this? This is the x-intercept. And that's the y-intercept. Oh my god, right? And Dareen, I think, yeah, Dareen, I call her Dareen. She taught me this last year, and so I was like, oh, wow. So let's take a look at this. Once again, remember, it was the negative I put down there. So let's take a look at this graph. Well, x is 5, y-intercept is negative 3. We know it's solid. I really should be using a ruler. Let me redo that. I apologize. So let's make the graph. We have the y-intercept, the x-intercept is 5, and the y-intercept is negative 3. let's see, we would know it's a solid line. The question is, who gets the shade? Well, we can't use that trick anymore. We're not really sure if it's above or below. So we can test 0, 0. We know that 3 times 0 minus 5 times 0 is less than or equal to 15. Is that true? Yeah. 0 is less than or equal to 15. So 0, 0 gets the shade. 0, 0 gets the shade. How are we doing for 25 minutes? Let me ask you a question then. So chocolate bars cost. So let's do a real world example, and then that'll be the lesson for the whole week. So that'll be inequalities. So here's an example: chocolate bars. It is 40 taka, and chips cost 25 taka, and you have 200 taka to spend. Now, unlike the test, you don't have to spend everything. So the question is, I want you to make a graph of all the possibilities. So I want you to think about that. What would set up a relationship between the chocolate bars, the chips, and the amount of money you have? And I want you to see if you can put a graph together. Write an equation. It's going to be an inequality, and then see if you make a graph. Okay, well, you know what? I'm going to let X be my chocolate. I'm going to let my Y be my chips. So what's the first relationship? Well, you say, okay, Mr. Adler, well, I know that chocolate bars are 40, and I know that my chips are 25. Now, in the test question, I had to spend all my money. But here, I'm saying, you know what, Mr. Adler, I don't have to spend all my money. So whatever this ends up being, it just has to be less than or equal to 200. Right? Now, there's one more restriction. So, but you say, well, I'm fine, Mr. Adler, and I'm just going to graph it. Because there's an equation here. And so you're going to do your graph, right? And here's your X, here's your Y, and you're going to say, Mr. Adler, I'm going to use the trick you taught me, Darren's trick, divide everything by 200. And so I know that 400 divided by 200, that's 1/5, so it's going to be X over 5. So the X-intercept is 5. And 25 divided by 200, that's 1/8. So the Y-intercept is 8. I'm going to draw my line like this. And so, and solid, so it looks like that. And then I'm going to test 0, 0. And 0 plus 0 is less than 200, and I shade everything, right? So once again, test 0, 0. 0 plus 0 is less than or equal to 200. So 0, 0 gets the shade. But there's one issue here. I want you to think about it. Is what's wrong with this graph? Or something's wrong. I mean, it looks right, but this is a real problem, real world problem. Yes, exactly. It turns out, if you think about it, X and Y, so what is the issue here? And you would say, well, you know what? X and Y have to be greater than or equal to 0. I can't have -3 chocolate bars. I can't have, -7 bags of chips. So the idea is we're going to take everything out. And so the answer only lies in the first quadrant. And that's it. Okay, I'm going to put some homework out. That's the homework for the week.